Under extraction of metals, let us now talk about extraction of lead. Extraction of lead. Well, the chief ore of lead is galena. Galena is PbS. It's a sulfide ore of lead. Let's see how lead is obtained from galena. We start from ore. The first thing we need to do is concentration of ore. This is done by concentration of ore is done by froth flotation, and this should be done in presence of NaCN, and I'll talk about the role of NaCN after a short while. Then we have concentrated ore. This is then subjected to roasting. This roasting has to be carried out in presence of limestone. And what is the role of limestone also will be made clear after some time. Then you get roasted ore. Roasted ore mostly consists of PbO. Of course, it will have some PbSO4 also. I'll write that also. PbO and PbSO4. Little amount of PbSO4. What happens, during roasting, some PbS will get oxidized to PbSO4. Then reduction. Here you have two pathways. You can go for auto reduction, auto or self reduction, or you can go for carbon reduction. Pb, and here also you get Pb. Here we use carbon, that is coke, as a reducing agent. Here we don't use any reducing agent. We make PbS and PbO to combine to give Pb and SO2. The final step is refining. This is crude lead. Refining is done and you get pure lead. So these are the stages for the extraction of lead starting from galena. Galena is first subjected to froth flotation in presence of NaCN. After this, you get concentrated ore. After this, we have to do roasting. This roasting will transform PbS into PbO. Part of it may get converted into PbSO4. Then we do either carbon reduction or we may go for auto reduction. It all depends upon this decision we take on the basis of presence of quantity of impurities present. If the impurities are in large quantities, then we go for carbon reduction. If very small amount of impurity is present, then we go for auto reduction. Lesser amount of impurity, auto reduction. More impurity, carbon reduction. Then the final step is refining of lead. Now I'll first talk about the role of NaCN. See, PbS is always associated with ZnS impurity. You will have PbS, ZnS, of course you will have SiO2. So these are the substances present in the ore. Now you will understand the role of NaCN. NaCN, what it will do is it will react with ZnS to give a soluble complex. ZnCN taken 4 times 2 minus. So in this way, NaCN will transform zinc sulfide into a soluble complex and it will not allow ZnS to stick to the froth during froth flotation, only PBS will stick to the froth. The advantage is PBS will not react with NaCN. PBS plus NaCN, no reaction. It selectively reacts with ZnS and transforms it into a soluble complex. In this way, NaCN is said to be acting as depressant. NaCN acts as a depressant for ZnS. It will not allow ZnS to get adsorbed or to stick to the froth during froth flotation. PBS alone will stick to the froth and can be separated. ZnS passes into solution as a soluble complex. That's about role of NaCN. Now let's talk about the role of CaCO3 during roasting. Role of CaCO3. During roasting, CaCO3 decomposes to give calcium oxide and carbon dioxide. Now calcium oxide will then combine with SiO2, the gang or matrix, and transform into a slag CaSiO3. In the absence of SiO2, there is every possibility that PbO will get transformed into PbSiO3. That means you are using limestone to bring about this reaction, and in this way you are decreasing the wastage of Pb as PbSiO3. This is one possible reaction. PbO plus SiO2 to give PbSiO3. This takes place to a very little extent. Why? Because calcium oxide is more basic than PbO. So calcium oxide will react with SiO2 preferably when compared to PbO. So wastage of PbO as PbSiO3 is largely prevented by adding limestone during roasting. I'll have to elaborate on auto reduction and carbon reduction and also talk about refining of lead. Let's talk about it. Go through the flow chart once again. We start with ore which consists of PBS. ZnS is associated as an impurity apart from SiO2. We do froth flotation in presence of NaCN. The role of NaCN is to prevent ZnS from sticking to the froth. Then we do concentration of ore. Then we do roasting. During roasting, we heat the ore in a presence of excess of air. This will remove all the moisture, this will remove all the volatile impurities, and this will transform sulphide into oxide. To some extent, it will also get oxidized to sulphate. Then we do reduction. We have two pathways, as we said, auto reduction and carbon reduction. Let us elaborate on that. See how reduction is done. Reduction. First, I'll talk about self reduction, auto reduction or self reduction. Here what we do is we start with this PBS, concentrated ore. We do partial roasting so that part of it gets transformed to PbO. After this, we do heating. This will bring about auto reduction and we get Pb plus SO2. Now what happens during partial roasting? PBS will get transformed into PbO plus SO2, and because we have done partial roasting, some PbO will be left out. So the left out PbO will combine with PBS and you get Pb plus SO2. If a sulphide of a metal reduces its own oxide, then the type of reduction is described as auto reduction. Apart from this, this is another thing which is possible. PBS is likely to get oxidized to PbSO4. This happens during roasting, and then The left out PBS will then undergo what is called as comproportionation. With this, sulfur is in the +6 state, here sulfur is in the -2 state. So, a type of comproportionation takes place and you get Pb plus SO2. So, these are the reactions which are expected to take place during auto reduction or self reduction. We do it like this: we concentrate the ore. After that, when we find that the impurities are less, we go for partial roasting, so that 2/3 of PBS transforms into PBO and the remaining 1/3 PBS will combine with 2/3 of PBO, 2/3 of that which has changed to PBO, and you get PB and SO2. If any PBS has been oxidized to PbSO4 during roasting, will also get transformed into Pb in this manner. So, this is how auto reduction is done. In auto reduction, sulfide of a metal will cause reduction of its own oxide to give metal and sulfur dioxide. Go through the equations once again. We go for partial roasting, so that 2/3 of PBS is transformed to PBO. Then we go for further heating in the absence of air, so that auto reduction takes place and you get Pb and SO2. These are the reactions which take place. Now, let us learn about carbon reduction. As I told you earlier also, carbon reduction is done when the impurities are more in amount. If you have large quantities of impurities associated with the ore, go for carbon reduction. Then we do what is called as smelting. Smelting is done in blast furnace. Here we take roasted ore, we mix it with coke and limestone, and this mixture is heated and we get Pb plus CaSiO3. This is slag. Let us see the reactions which take place during carbon reduction. This is one type of reaction which is possible, Pb plus CO. Apart from this, PBO may also get reduced by carbon monoxide and you get Pb plus CO2. Then the limestone will decompose to give CaO plus CO2. Then CaO, this is the flux, it will react with gangue, that is matrix, and get CaSiO3, which is called as slag. These are the reactions which take place during carbon reduction. Calcium silicate separates out as slag and you get molten lead. The reduction may be brought about by carbon as such, or carbon monoxide also can bring about this reduction of PBO into Pb. Now, the final stage in the extraction of lead is the refining of metal. Refining means purification, refining of lead. We have crude Pb. The impurities are copper, silver, gold, arsenic, antimony, bismuth, tin. These are the impurities associated with lead. All these impurities will make the lead very hard. So, when you remove these impurities, lead becomes soft. So, that is the reason the process can also be regarded as softening of lead. Heat, pass lots of air, then you get a scum of metal oxides. most of the metals in this list will get oxidized and it will form a scum of these metal oxides. Now you have lead. This time this lead is associated with silver and gold impurities. The number of impurities have been cut down to only 2. You had several impurities. On heating the impure lead in excess of air, most of the oxides have been removed as scum. You got a lead which is now associated with silver and gold. Now you do what is called as Parkes process. This will remove silver. Now this time you have lead along with gold. Now I'll explain you what is Parkes process. Here we add zinc. Zinc is added to impure lead. Zinc has an ability to dissolve silver more than lead. Zinc can, silver is 3000 times more soluble in zinc than in lead. So when and zinc and lead are immiscible. Zinc and lead are immiscible. So when you add zinc to molten lead, you get a molten layer of zinc on the surface of lead, and this zinc will dissolve all the silver. Silver from lead will be transferred to zinc because it is 3000 times more soluble in zinc. So all the silver will be transferred into zinc, and this is easily removed because it has formed a separate layer. After removal, silver can be recovered from zinc by distillation because zinc is a low boiling metal. So the metal used for the purpose is zinc. Silver is 3000 times more soluble in zinc than in lead. Another point you should know, see, zinc and lead are immiscible. Solubility of silver is more in zinc, roughly 3000 times. These are the 2 points involved in this, which form the principle for Parkes process. So we can comfortably recover all the silver from the lead and make it free from silver. Now we are to deal with mixture of lead and gold. Let's see how it is done. Lead plus gold, you do Betts electrolysis. This will remove gold and you get pure lead. Now here the anode is impure lead, cathode in the Betts electrolysis, cathode is pure lead. Anode is impure lead, cathode is pure lead. Electrolyte is PbSiF6 plus H2SiF6. H2SiF6 is called fluorosilicic acid, and here you have a salt of fluorosilicic acid, plumbous salt of fluorosilicic acid. So this is the electrolyte. Anode is impure lead and cathode is pure lead. So by doing Betts electrolysis, you can purify lead. All the gold will fall down as anode mud. This is complete information regarding extraction of lead. We have said the chief ore of lead is galena PbS. It is to be concentrated by froth flotation, then it is roasted to convert it into PbO. Then we can go for either auto reduction or carbon reduction. Then purification, we have several metallic impurities present in lead. We need to first heat it in a blast of air and then do Parkes process where we add zinc, it removes silver, and then we do Betz electrolysis to remove gold, which comes down in the anode mud.